Waves obey the principle of superposition, and it's a pretty amazing principle to demonstrate. Let's use an example. Suppose I have a string. So here's my string going along, and on one side it's pulled tight. I'm standing on this side, my friend's standing on this side, we're pulling it tight, and then I give it a little whip, causing a little pulse to travel that way. But my friend does the same thing and gives a little pulse traveling that way. Okay? Now, if you've ever done this, you take a rope and make it kind of tight and just whip it, you'll see that pulse travel fairly fast down the string, and it slowly dies out because of resistance and losses of energy as it travels along. But we'll assume a case where there's no energy losses at all. So this pulse is going to travel along, this pulse is going to travel along. The question is, what happens when they reach each other? And so this will travel along, and assuming it gets, to right there. This one travels along, and let's assume it gets to right there. Still moving that way, and they start to interact. So the reason why the pulse happens is because there's an upward force right here on the next piece of string that gets pulled upward, whereas back here this piece of string gets pulled back down because of the tension in the string, and so that pulse just moves along. Okay, and so that means this piece of string right here is being pulled up now by this side and this side, and it's going to be pulled up towards the middle, and you get this larger bump as the two waves come to the same location. It pulls it all the way up. Now you might say, that's interesting. Now I have one pulse. What direction is it going? Well, if you tried to think about this in terms of like, these are two balls and they hit, but they merged. This is like two balls of clay, it seems, and they hit and they turned into one ball of clay. But superposition is a type of motion or a type of interaction that is not like balls of clay. What happens next is the pulses travel through each other. And that is really interesting. We can, and in this class we'll often just talk about how they just can pass through each other as if they didn't change each other, and only when they're overlapping the same space will they add together to create something new. But it's actually a really intriguing problem to go and look at the molecules of the string and what's happening and why this works. It's a really intriguing discussion, but it is beyond the scope of this course. But the end result is that, yes, they did merge here, but the momentum carried by those pieces of string continue as if they never did anything together. They just kept going. They passed right through each other. So this pulse was this one, and it continues traveling on, and this pulse was this one and continues traveling on as if nothing happened. That's the principle of superposition, and it's pretty amazing. As another example, let's suppose we do this again. I'm going to truncate and make it a little smaller, and I give this upward pulse, but my friend gives a downward pulse. My pulse travels towards my friend's pulse travels towards me. The amazing thing here is this principle of superposition says that when they get to each other, this one moving that way, this one moving that way, assuming they're identical pulses in all regards except one's upside down and moving the other way, that the next moment when they occupy the same space, there'll be nothing. It seems, okay, it disappeared. But guess what happens in the next moment? That's right. They pass through each other. When the string was totally flat, okay, it looks like there's nothing there. There was still momentum. These pieces of string were getting ready to pull down. They had a velocity that we can't perceive, but they were getting ready to be pulled down, and they passed through each other. As if they never interacted with each other. That's the principle of superposition, and this is true. We can do experiments to test this, and we'll do some examples to quantify this for some story problems. But this is an amazing principle, and it applies to all waves. That they don't change each other. They do interact, causing the medium that they're in to add according to their shapes, but they don't change each other's effects. They continue to pass through each other. And we'll see some really cool effects that we use in our daily lives because of this.